Hi, welcome back. This is section 2.4 on formulas and percents. So you can imagine you're in biology class or you're in a physics class or something like that, and you're working with a lot of formulas. We all have heard of the formula E equals mc squared. And oftentimes we need to solve for one specific variable, and that's what we see here in the beginning of section 2.4 in the homework. So let's dive in here. There's also formula work with percentages and some other types of story problems we'll see on the way. So let's without further ado, let's dive in. This is number 3. I have j equals 9 pi times p, and they want you to solve for p. Okay, first things first, if you have a capital J, like I have, when you write in your answer in the computer, you're going to have to use a capital J. So what am I trying to say? I'm trying to say it's case sensitive. Okay. The way we approach these is similar to how you solve equations. You're going to be using the addition property, also the multiplication property. The only difference is you can't combine things together, right? If they aren't like terms, you cannot divide them. You're not going to be able to add them together. So you end up kind of just moving the variables around and placing things on one side as opposed to the other. Anyways, let's try this one, right? So we want to get p all by itself. So we're going to use the multiplication property, in this case, divide both sides by 9 pi. Okay. On the right side, the 9 pi's will cancel. On the left here, we just have j over 9 pi. And so, you've isolated p, and that's basically your answer. We always want to write with the p on the left, the thing we're solving for, you put that on the left, and everything else on the right. So again, when you put in your answer, you're case sensitive, so it's capital J all over 9, and then for the pi symbol, you can type in backslash pi, and it'll automatically put it there, or you could use the little button below. Okay, everything else is just kind of variations on this theme. Let's take a look at number 4. It's very similar. The only difference is we have a f raised to the 4th power. So I have b equals mf to the 4th power. We want to solve for m. And so again, what we're going to do is just divide both sides to isolate the m term, or the m factor. Okay, so if I divide both sides by f to the 4th, I'll have b all over f to the 4th equaling this m, and there it is. Right, so m equals b all over f to the 4th. Again, remember to use a capital letter B in the numerator, and then in the denominator you go f, and then I usually just hit the caret key, and it'll give you the exponent. Okay, so number 5, a little bit more work involved here. We have to use the addition property. So number 5, we have y equals dx plus m, and we want to solve for d. So first things first, I'm going to move the m to the other side. So you always do the addition property before the multiplication property. And then we could divide both sides by d, and have to divide all of the left-hand side by d. So just put a big division symbol and then the d in the denominator. So you'll have y minus m all over d, which equals just plain old x now. And then you could rewrite your answer as x equals y minus m all over d. Okay. And then type in your answer. You need a fraction bar in the numerator, y minus m, and then all over d. Oh, I solved for x. Sorry about that. I solved for x. So it's actually, I need to y minus m equals d times x. So I'm going to divide both sides by x. Okay. Sorry about that. So you get y minus m all over x equals d. And then, of course, d equals y minus m all over x. there should be an X down there. Surprised I didn't see that. Okay, maybe skip ahead a couple here. Here's a fraction. So generally when you have a fraction, you want to multiply to get rid of it. Let's see if we can maybe jump ahead to, sure, let's do number 7. Okay, so number 7, here I have h equals 1/4 v times b, and I want to solve for v. Okay, so off the bat, I'm just going to get rid of that 1/4 by multiplying both sides by 4. So I'll have 4h over here, then 4 times 1/4 times vb. And then I have 4h equals 4 times 1/4 is just 1. So I'll have 1 times v times b. We don't write the 1. And then finally, isolate v by dividing both sides by b. And so we have 4h all over b equals v. And then rewrite it with v on the left. So just flip-flop the sides, and we should have our answer. So 4h all over b. Oh, kind of hyper with the fractions are. Okay, so if you see the fraction, generally we'll multiply to get rid of it. Here's another one with a 1/2 fraction, problem 10. You have a equals 1/2 times m plus d. So you can distribute, but you can also just right off the bat multiply both sides by 2. Okay, so it'll be 2 times 1/2 times the m plus d. So on the left you have 2a. On the right, 2 times 1/2 is just 1. So we have 1 times m plus d. And if you distribute the 1, of course it's just the m plus d. So you need not write this step that I just wrote. You could just write m plus d. Okay. All right. What the heck are we solving for? We're solving for m. So I'm going to go ahead and subtract that d to the other side. It's minus d. I get 2a equals m. 2a minus d equals m, and then flip-flop sides. So m equals 2a minus d. It has to be a capital A. So we get 2a minus little d, and then check my answer. Yay! All right. Some of these are actual formulas for different geometric objects or things like that. Okay, so then we get in the percents. Let's at least do one more here. We'll do number 12, and then we'll move on to percents. Okay, so we have c equals 1/3 h times s plus z, and we want to solve for s. You can approach this the same way as the last problem. Just first get rid of the 1/3 by multiplying both sides by 3. H times s plus z. And then, of course, you get 3z. On the right, the 3 times 1/3 is just 1, so you have 1h times s plus z. And then you could distribute the h. And then you want to isolate the term that has the s. Okay, so you want to get that thing. I just put it in the box by itself, so I'm going to move the hz to the other side. So I have 3c minus hz equals hs. And then to isolate the s, I'm just going to divide both sides by h. So I have 3c minus hz all over h equals s. And of course, we want to write the s on the left. So that would be 3c minus hz all over h. Let's put that in there and see how it likes it. Again, capital C, so be careful, minus hz all over h. Okay, so let's move on to the percent problems. And each of these problems orbits around the formula A equals P times B. So translating this into English, it's, you'll say, A is P percent of B. And P in the context of the equation is going to be used as a decimal but if you talk about it just between other people, you're going to convert it into a percent, right? So in this problem, you see it's written as a percent. So you have in problem 14, what is 5% of 900? So you're going to say A, the what is equals 5%, but you're not going to write 5, right? You're not going to do that. 5% you need to convert to decimal by moving the decimal point. So you have 5 with the decimal point here, so you have to move 2 places to the left. Okay, so 5% as a decimal is 0.05, and then of 900, so times 900. And then I usually just default to my calculator for any story problems. Oops, I didn't want that thing. Let's get the calculator out. So we need to go 900 times 0.05. And so 45 is 5% of 900. Okay, and then from there, all they do is kind of like variations on the theme. So they'll give you A or they'll give you P. I mean, they won't give you A or they won't give you P or they won't give you B. So in this problem, number 16, they're not giving you B, right? So 26 equals 65%. So to convert 65%, you need to move that decimal over 2 places. So it will be 0.65 of B. And so in this case, you have to solve for B. And it's just merely a matter of isolating B using the multiplication, or here it's the division property. I'm going to get to my calculator. 26 divided by 0.65 is 40. So I'll have 40 equals B, or if you'd rather, B is 40. Okay, so 26 is 65% of 40. Check the answer. Yay. They'll try to mix it up a little bit on you. So in this one, it's not clear. It's not in the order A and then equals P times B, right? They give you P first. So 17, the P value is the 26% as a decimal, 0.26. Is 26% of what number? So B is unknown, equals 46.8. So A is the 46.8. Okay. So to set it up as an equation, 46.8 equals 0.26 of B, which we don't know. So to find B, I'm just going to divide both sides by 0.26 and go to my calculator. And it looks like B is 180. You want to be a little careful when they start asking for percents. The problem is converting back from decimal to percent form, so you have to move the decimal to the right 2 places as opposed to the left. So anyways, in this problem, 64 is, in other words, equals what percent? P of means multiply 80. Okay, so divide both sides by 80. Flip-flop sides eventually. So 64 divided by 80 is going to give you 0.8. And of course, that's not the answer, right? As a percent, we need to then move this decimal 2 places over, so it'll be 80%. So we'll type in 80. 64 is 80% of 80. That doesn't hit the tongue, right? But there it is. Okay, and so on and so forth. Everything else is just kind of variations. Percent increase, percent decrease problems. So it's kind of the same formula. It's just for the A value, you're either going to do a difference or a sum. So it's for percent decrease, what you're doing is a difference between 2 values is equal to some percent of some number. For percent increase, you're looking at a difference, again, between 2 numbers. and setting it equal to P times B. Let's make that a little more clear. In problem 20, we have if 15 is increased to 18. So what this increase is what percent of the original number. So to get the increase, you're taking 18 and subtracting away 15. Okay, that's 3. So that's what you use on the left side for your A value. Okay. So 3 is going to be equal to what percent, so I don't know the P value, of the original number. And the original number is the starting number. So we started with 15 and increased it to 18. So it'll be 15. And then we just divide both sides by 15. 3 over 15 is the same as 1 over 5. So I'll be 0.2. And converting it by moving the decimal 2 places over, we'll have 20%. So 20%. The decrease problems work kind of the same way. It's just you're you're subtracting the first term minus the second instead of the second minus the first. So this 18 in the previous problem is kind of where we ended the end term, and then the 15 is where we began. Now it's kind of reversed for the percent the decrease, right? So we'll take the beginning term, the 15, and subtract away the end term, which would be 6, and that overall will be the decrease, right? So the first one was an increase, and then the second one here is a decrease. But at the end of the day, it's still just going to give you the A term, so 15 minus 6 is 9. That'll be your A value, and then you plug it into the formula. So the decrease, which is 9, is what percent P of the original number. So the original number is your beginning number, which is 15 here. Divide both sides by 15, get 9 over 15. So P is, divide both top and bottom by 3, 3/5. 3 divided by 5, 0.6. And so that'll give me 60% when I move that decimal. Okay, so a little bit more work, but it's fundamentally the same equations that you were using in the previous problems. Then I think the last couple problems are mainly just more practice with solving formulas. Let me just make sure, and then I'll start kind of going through some of them. And then we have some story problems, sure. Okay, so let me hit a couple more of these later formula problems, sometimes call them literal equations. And just in case you're struggling with one of these, let's try number 23. Y equals A minus K times X plus 3, and we want to solve for X. Okay, so here I kind of want to isolate anything that's attached to the X. When you get that blue box all by itself, I'm just going to minus 3 on both sides. Right? And then you'll be left with A minus K times X. You may be tempted to distribute here, but that's going to kind of make you go in reverse. What you really want to do is divide by this A minus K expression. So on the left, we'll have Y minus 3 all over A minus K. On the right, the A minus K's now cancel, leaving us with X. So we'll have X is Y minus 3 all over A minus K. So we'll put that in, need a fraction bar, so slash key Y minus 3, arrow down, A minus K. Check. Yay. This one, 24, the deal here is it kind of looks like they distributed an X through the expression. And another deal is my pen isn't working. So hold on, I'm trying to fix it. There's a little button on the side of it. It's supposed to be for like artists and stuff, but turns out to be a hassle for us teachers. Just talking about the pen I use to write on this board here for the video. Anyways, that x, you can imagine as having been distributed, right? So the way you want to do it is to undistribute the x, and we call that factoring out the x, okay? So if you just write it like this, you can kind of see, okay, if somebody had distributed the x, you would have gotten back to where you started, right? X times c is cx, and then x times k is the kx. And we're solving for x, by the way. Okay? So once it's in this form, it becomes just like the problem above in that second step where we divided a minus k. Here we want to divide c plus k, right? On both sides. So we end up with y over c plus k equals x. Flip-flop the sides to get it in the right order. Y over c plus k. And everything's lowercase. Backslash y, arrow down, c plus k. And yeah, so this one is similar as well. You're going to have to move the t and then factor out the x. All right, so let's get that real quick. Y equals dx, capital Dx, minus capital Bx, minus capital T. I'm going to move the t first. So I can't factor the x out of all three of those terms because not all three terms have an x. So I'm going to move the t over by adding it to both sides, right? And then you just have the dx minus bx. Both of those have that factor of x. So I can factor out the x and just have the d minus b. It's a reverse distribution, right? Okay, so once I get it there, I'm going to divide both sides by this d minus b. Flip-flop sides, the d minus b's will cancel, and you'll just have x equals y plus t all over d minus b. Okay, be careful with your lowercase uppercase, so lowercase y plus capital T all over capital D minus capital B. And, ooh, I got too many minus signs there. Yay. Okay, this problem number 26 is good for people who are trying to figure out their grades. In my class, you could really get a good idea of what your grade is just by averaging the test grades. Okay, all my tests will be out of 100 points. Anyways, let's look at this guy, right? So the average or mean T of 3 exam grades S, X, and Y is given by the formula T equals S. So you just basically add your exam grades and divide by 3, and that gives you the average. Okay, so they're saying we want to solve for Z. So we want to change this formula to make it a little easier to work with if I don't know what Z is. Students are always asking me, what do I need to get on this test to get an A in the class? And this is the kind of operation you would do. So you're solving for this unknown test. Maybe you haven't taken test Z yet, and you want for T to be a 90%. So you want this to be 0.9. We know what S is. S is given as 86. So instead of writing it as a decimal, you can just write it as 90. You want everything to be kind of in the same form, right? So I'm not going to use 0.9 if I don't use 0.86. Okay, so the T, we want an average grade of 90% to get this A. I got an 86 on the first test. I got then an 89 on the second. And I want to figure out what I need on the third, right? Okay, so I'm gonna change it into a formula for Z, and it's going to tell me exactly what I need on that third test. So I'm going to multiply first to get rid of the 3. So again, write in the formula. I'm going to multiply both sides by 3. On the left, I have 3t. On the right, the 3's will cancel out, just leaving me with s plus x plus z. And then you could solve for z by minusing the x and the s to the other side. So I'd have 3t minus x minus minus S minus X is Z, and then flip-flop sides. And you can then substitute in those values that you got on the test, right? So I want a 90 in the class, so I put the 90 there. And then I put the 86 in for S and the 89 in for X. And then you're just going to your calculator if you need to. So it's 270 minus 86 minus 89. And it looks like you need a 95 on the test to get a 90% of the class. And so basically, if you're getting B's on the test, you're going to need an A in order to end with an A in the class. Okay. Let's keep moving here. Let's try this previous one. It's 27. So the formula for figuring out distance, if you know a rate, is D equals RT. So if you're going 30 miles per hour for 2 hours, you've driven 60 miles. You just multiply the rate times the time. So anyways, this is 27. Our formula, again, D equals RT. And so first part A, they want you to solve for T. Okay, no big deal. I'm going to divide both sides by R. So I'll have D over R equals T. Then I'm going to flip-flop the sides. T equals D over R. Part B, use the formula in part A to find the time you travel if you cover 90 miles at an average rate of 60 miles per hour. So the time will equal, so it's a distance of 90, so D is 90, plugging and chugging, all over the rate, which they're saying is 60. Okay. So it'll be 9 over 6 versus 3 halves, which is 1.5. It's miles per hour, so the time units are hours. And so I believe 1.5 hours. 1.5 row. What did I do wrong? The distance of 90. Maybe they want me to put the time units in. Sorry, I'm baffled. I have no idea. My brain is like, no, it's right. I have to put hours in there. I can't imagine having to put hours in there or something. Oh, they just want the formula. No wonder. All right, well, lesson learned. Got to read directions. Well done. And then, yeah, 1.5 hours. Sorry about that. Yay. All right, this last guy surveyed 2,400 workers as participants about, a taboo subject. The circle on the graph on the right shows the results. Among the 2,400 workers who participated, how many stated that religion is the most taboo subject? Basically, they just want to know how many people are 29% of 2,400, right? So you're thinking 0.29 times the 2,400, and that'll tell you how many of those are thinking that religion is something you want to avoid. Yeah, definitely at the job, I avoid religion and I avoid politics more than anything else. Gossip, it's a good idea to kind of keep away from the teacher's lounge for me. They definitely warned me, don't go in the teacher's lounge. They just sit around complaining all day long. So definitely good advice from the homework problem. Let's see what that is. 0.29 times 2,400. I mean, we're here to learn math, so I guess it doesn't really matter, but let's see, 696. 696 people said that was the major issue. I kind of agree. Anyways, okay, great. So I hope that helps with you and the problems. As usual, if you have any issues, come see me during my office hours. I'd be glad to walk you through a problem or two. Other than that, we'll see you next time, and have a good one.